Okay, so conic section, sorry for my voice, it's a little weird right now, I'm getting over a cold. Conic sections involves parabolas, circles, ellipses, and hyperbolas. You can see here if you were to slice this cone here in different ways, it can create the different types of shapes. There are formulas for each of these. You should be familiar with equations of circles from high school geometry. There's a typo here. That should be a minus sign. So you should be familiar with that from high school geometry, and you should be familiar with parabolas from Algebra 1. So let's look at it's good to be able to memorize these formulas, like their standard form. It's like in Algebra 1, they tell you, hey, slope-intercept form is y equals mx plus b. Okay, it's kind of like that, but for circles and ellipses and things. So a circle, I'm just going to put it with the vertex at 0. Equations of circles look like this, although you can change where its center is. You know, you can put it at, for example, you can put the center at 2, 2, which you can see here, 2, 2. And the radius, I can make 2, right? There it is there. So the formula is x minus h. So x minus your hk. Your hk is your xy coordinate for the center of the circle. This is radius squared, right, which is 4. So that means the radius is 2. So if you go backwards, pretty much, take the square root of that, you get the radius. Look at this, you get the the center. So if it's a negative, though, you're going to see a positive sign, right? I changed this to a positive sign. You can see the center is now at -2, -2. And so that's equations of circles. So we should already be familiar with parabolas in vertex form, right? Y equals x minus or x squared, right? This is a parabola. It can go upward, it can go downward, right? But they can also go left and right. You can see here this says x equals -y squared. It makes it go to the left. Now it's to the right. So all you have to do is change it from a negative to a positive to see which direction it'll face. And so you can change the vertex by changing vertex form, right? They teach you that in Algebra 1. Let's say I want to make the vertex 2, 2. I do my HK, which is the vertex, or whatever you want to call it, HK, XY. There's my vertex, right? I can make this a -2 by putting a positive sign there. And the reason is for this, when you plug in the formula is x minus h, right? So when you plug in a -2, it becomes a negative, which becomes a positive. So just so you know. So I like to tell students it's the opposite of what you see for that there, right? If you see a positive, then the vertex is at a -2 for x. For the y, it's what it appears to be. So, you know, the vertex is at -2, 4, -2, 3, or -2, -2, or -2, -5, right? So let's just put it back here for now. And the A, which is in front, if you make it bigger, it will get skinnier. It does a vertical stretch. If you make that number in front smaller, it does a vertical shrink, which is a horizontal stretch. You can see here it's getting wider. So you can play around on Desmos to kind of see how these equations work. Okay, so that was for parabolas. So I did circles and parabolas. Now let's do ellipses and hyperbolas together. So the difference between an ellipse and a hyperbola is this has a plus and this has a minus sign. This is always going to be equal to 1. Okay, so let's start with an ellipse. So you can change the denominators here. and it'll just make it like shaped like an egg, right? So you can see here, up and down, this is 5, left and right, this is 4. And that's what the square root of this is. Square root of this is 4, square root of that is 5. So for the x-axis, it goes left 4, right 4. It tells you the vertices, right? If you take the square root of 16, you get plus or minus 4. So that's where the co-vertices is, we would call them. The major vertices or the main vertices or whatever you want to call it is the square root of 25, which is plus or minus 5. The reason why this is the main vertices is because it's the bigger number. If I were to switch it, this would now be the main vertices, and this would be the co-vertices. So you can see the co-vertices is 2, right? It's at 0, 2, 0, negative 2. We know how to find coordinates. And the main vertices is at 4, negative 4. Okay, now let's change this to a minus sign. Now it becomes a hyperbola. So here, same thing, you take the square root of the top and bottom. So since the x comes first in this formula here, let's write a formula that looks like it, but let's have it be with the y first. I think I swapped the numbers there. So you can see how now it goes up and down, right? Even if I put this for 4 and this is 25. So here, all I did was change this to the y first, right? And this to the x first. So I just rearranged the order. So when the x comes first, it's going to be on the x-axis. When the y comes first, it's going to be on the y-axis like this. And so you can see for the first one, take the square root of 25, you get 5, right? Which is here. For this one, you take the square root of 4, and you get 2, which is there. And so that's how you can like play around with and see how the different formulas make different things. And so those are all of them. And so you're also going to learn about foci in this section. And so the foci will be like a point, like let's say I graphed a parabola. And so they're going to ask you, find the foci or something like that. Find a better diagram. And so the foci, let's see. The foci is also known as like the focus. The focus is the same distance from the directrix, and you might have learned about this in geometry. It's the same distance from the distance from the directrix is the same to the foci. So let's say it's there, right? It's the same distance. That's what that is. And so we're going to learn how to find them. So when you have y squared, this is for parabolas, when you have y squared equals 4ax, you can use these formulas to find the foci. And don't worry, we're going to do that more in the unit, but just kind of play around with the different shapes and know about the different shapes first. And now let's jump into the unit. Okay, so it says write the equation of the ellipse graphed below. So where is the center here? Okay, so this is over 2, this is over 2, right? So 2, 2 for the x's, right? So that means, so let's just write the equation of an ellipse as is. So it's x squared plus y squared is equal to 1. And we know we're going to have in the denominator 4 because 2 squared is 4. And then for the y's up and down here, what do we have? 1, 2, 3, 4, what is that? 6 units. 6 squared would be 36. Wait, hold on. It's supposed to be Oh, I forgot about the center part. Sorry. Okay, that part's correct, but also the center, I forgot to add that. So the center is at 7, -2. So it's just like equations with circles. We need to put it with the x squared and the y squared. So it's x minus 7 squared, y minus -2 squared, which becomes y plus 2 squared. And that's how you would write the equation of the ellipse. You have your center, you have your co-vertices, main vertices, and that's that. Okay, so by looking at that, what's the center? It's the opposite of what you see, right? Which is -4, and this one does have nothing, so it's 0. So what's the major radius? It's the big one, the square root of 25, which is 5. The minor is the square root of 1, which is 1. Very simple. Okay, what are the foci of the ellipse? So we have to find it. So we know that our center is at 5, 7, right? So we can write our center is at 5, 7. Our uh, our minor vertices is the square root of 3, and for the main one, it's the square root of 6. So the foci is going to be on the main vertices. So you need to focus on this number here. So you are going to be using like Pythagorean theorem. You know, they say a squared plus b squared is equal to c squared. Well, since distance is equal to each other, let's look at the formula for this one. So since the distance, the foci of an ellipse are always located on the major axes and are the same distance away from the center of the ellipse. We can find the distance by using this formula. So f squared equals p squared minus q squared. This is an important formula. Feel free to pause the video and write that down because that's an important one. And so you're going to do your bigger number squared minus your smaller number squared, which is what they did. So f squared equals the square root of 6 squared minus the square root of 3 squared, which is just going to get you 6 minus 3, which is the square root of 3. Therefore, each focus is square root of 3 units away from the center of the ellipse. Okay, so the center is at 5, 7. And so remember, it's going to be on the major axis. So we need to look at this number here, right? Since this is on the major axis, which is our y, we need to add the square root of 3 and minus the square root of 3. And so that's why the answer is A. We added the square root of 3 minus the square root of 3. So I do recommend doing the individual quizzes on Khan Academy, practicing finding the foci, because that part can be a bit tricky. Write an equation of the ellipse centered at the origin, which has the foci of this and vertices of this. Okay, so it's centered at the origin. So we know it's just going to be x squared plus y squared equals 1. For the denominator, so far we have the vertices for our major axis here, which is y. And so we square it. Remember, we square it. The square root of 89 squared is just 89. So we need to find our other one. So we know our f squared equals our p squared minus our q squared. And we're looking for q squared. So this is going to get you 55 equals 89. And so we need to solve for q squared. So 55 minus 89 gets me -34 equals negative q squared. Divide both sides by negative and you get 34 equals q squared. And so q is the square root of 34. And when you square that, you just get 34, right? So q is the square root of 34. And so we need to make sure our numbers are squared here. So we use the foci to find our co-vertices and then write the equation for the ellipse. Plot the foci of this ellipse. Okay, well, the center is at 0, 0. The major is 15. So let's write the equation of this ellipse first. by just looking at this. This is 15 squared, which is what? 15 squared is 225. This is 9 squared, which is 81. Okay, to find the foci, I need to do the bigger number minus the smaller number. So it is 15 squared minus 9 squared, which gets you this. And so 225 minus 81 is 144. So your f squared is equal to 144. When you take the square root of that, that's plus or minus 12. And so you need to plot that on your graph. And there it is. The foci is always going to be inside the ellipse, right? It's the distance from the center. And so there it is for ellipses. Good luck. Let me know if you have any questions.